I'm pretty chill for that because normally if there is an exam, we don't have any home assignment and you just have to review for the class. But yeah,
yeah, just studying. And then, yes, this is actual work. Yeah, I feel, yeah. The homework this week, well, I think the first question I sort of figured out how to do, but the second one I'm struggling with.
okay.
I want to go over that. If you have looked at it, I'm not sure.
Sure.
Let's see. Where did it go? Oh, here we go. Yeah, so they're both two questions from the textbook.
Yeah.
Well, to be honest, the answers to the first question were in the textbook, so that was helpful.
Okay.
The second one, I'm not sure about. And then I also have questions on the first one. Do you have it up?
Yeah, I have the question.
Okay, cool. So for part A, I'm assuming, so the answer is 2.5%, right? So is that just like intuitive? Obviously, like 2.5% of people get in crashes, so they expect to lose money on that.
Yep.
Okay, cool. That makes sense. So for the second part, suppose a company writes 1,000 policies. What is the probability that they lose money on this set of policies? So are you just basically then taking, so you take the probability, well, let me see, what is N? N is 25. Or the mean is 25.
Yep.
And that's because that's 2.5% of 1,000.
Yeah. Yeah.
Okay, 1 sec. Okay, yeah, so the mean is 25 because it's 25% or 2.5% out of 1,000. Okay, and then you just find the standard deviation by doing, or yeah, so you do 25 times the complement of P, right?
Yeah. That's
So
correct.
you're doing 25 times 1 minus 2.5%. So it's just 25 times 0.975.
Yeah.
Okay, so, okay.
So
I think,
basically, it's a binomial model, so you can use the formula here. This one, the last two formula, is basically the expected value, which is the mean you just have said, and the variance. And to calculate the standard deviation, you just take the square root of the variance. Basically, it's NP and NPQ. And NP, which is like 1,000 times 2.5%, and NPQ is 1,000 times 2.5% times 97.5%. And yeah, it's just what you have said. So you have calculated the expected value and the standard deviation. But just remember, you need to take the square root of the variance to get the standard deviation. Yeah.
okay. Yeah, because the answer gave me, right, it gave me one number, then it's like the binomial model gave it another number, which is why I was confused. So the binomial would just be N times P times Q.
Yep.
Okay. Got it. Okay. And then for C, obviously it's yes, because the more that they sell, the lower the risk is.
Yep.
All right. Cool. Okay. I get that one.
But for B, do you have to apply for the central limit theorem to calculate the z-score in order to get the probability, right?
So I have to use the z-score for that?
Yeah, because you have to find the probability, right? You, you, you just find the expected value and the standard deviation, but that's not enough.
Okay. He didn't really show us how to use the z-score. I know I used it in college when I took stat, but I don't remember how to. So I guess I know how to find the z-score by using that, but how do you find the probability?
Okay, sure. So first you need to find three parameters here. You find the mu. Mu is your expected value, and this the denominator is your standard deviation. But what is the x in this question? Like I have a distribution with with the mean 25 and the standard deviation, I guess it's around 5. But what is my what is the what is the probability that I observe a number of x, right? But you have to understand what is the x in this problem, right?
Oh, yeah.
It says like what is the probability of not losing money, I guess. So you should find out um, for how many number of accidents observed the insurance company will not make money or in that break-even situation.
Okay.
So you need to calculate like using the number of, I guess, like 1,000 people and like 2,500 profit per people. And like if there is accident, the company needs to like compensate 65,000. So you need to use those numbers to calculate what is the break-even situation.
Okay. Um, so because then that's the complement of how many times they lose money.
Yeah, like because it asks you to find out what is the probability of losing money, right? So you have to find a break-even situation where the company is neither winning money, gaining money, or losing money, and that is like how many numbers of accident observed among the 1,000 insurance being sold.
Why don't you include when they make money too? Like, why do we have to find the break point? Because I guess that distinguishes the two. So it's either like you lose money or you make money.
It's the same. Like when they don't lose money means the money they gained and the money being compensated are the same. So that's a break-even point.
Okay.
They neither win or nor lose, because that is the point you want to get for this x. This x is the number you want to find.
Right. So am I doing then like for the z-score? Are you doing? Yeah. So then what is the x and the z-score to find the z-score?
Yeah.
Let's see. So z-score equals x minus 25 over 0.5.
The standard deviation should be around 5. I didn't calculate that, but it's
Yes.
close to the square root of 25. So
Right.
yeah.
You can do it on my. I think I got the standard deviation was 24.375. Then you do the square root of that.
Yeah.
Let's use my calculator that I didn't bring. Square root of 24.375. Oops. Square root. $4.937. Oh, I got that. Okay. So then still have to figure out what x is.
Yeah. Like I have a distribution already, and I want to calculate the probability of finding a number greater than x, or like finding a number in a limit from one number to another number with this probability mean 25 and the probability and this distribution mean 25 and distribution standard deviation around 5. But you need to know like what number or what limits, what range of numbers you want to find in order to calculate the probability, right?
Wouldn't it be like 0 to 1,000 because they're selling 1,000 policies?
Nope.
No. Is it the mean plus or minus a standard deviation?
Because here the x is like how many accidents you observe, like
Oh.
that mu. What is that mu? That mu 25 is the expected accidents among 1,000 insurance being sold. So what is the number of accidents caused the break-even situation? If you are the insurance seller,
Yeah.
you don't want too many accidents, right?
Right.
So there is like a range you can accept with like less than how many accidents I can still make a profit.
So yeah, so would it be like 25 because that's what you would expect plus or minus a standard deviation? So like 25 plus 5? Or no, that just means like the like range of probability.
Yeah.
Okay.
But you need to use the number, the profits and the compensation in the question to calculate like how many accidents is acceptable.
So are you doing, well, what is the probability that somebody loses money? See, I'm confused because I thought it would just be like, this might be stupid. This is my original thought was, wouldn't it just be like 25%? Oh, I guess that's not the probability that they'd lose money. I don't know. I'm confused now.
So how many
I think
money?
the probability that they would lose money in the set is still like 2.5 because that's how many accidents there would be.
Yeah, but that's a single insurance being sold. Here, like you don't want to see too many accidents, right?
Right.
But why is that?
Because the more accidents, the more money to lose.
Yeah, every accident you lose like 65,000, right?
Right.
So how many accidents is acceptable? Which means, so first by selling 1,000 insurance, how many money you gain?
Oh, 650,000. Oh wait, no. So the policy is, well, we don't know how much a policy is, do we? It would be 1,000 times however much the policy is.
Yeah, 2,500.
Oh, from the first question, duh. Okay, so 25,000.
Yeah, and one accident costs you 65,000.
Okay.
So how many accidents is it's acceptable when you are still making a profit?
Oh. So 45,000? Right, because 65 is the amount per accident.
Yeah.
Okay. Well, 0 then.
No, you can have some accidents actually, because I'm already gained like 2,500 times 1,000, right? That's the money I make.
Right. So
And then for each accident, I have to give away 65,000.
okay. So why did I do my math wrong? So they're making so the total that they're making out of the policies is 2.5 million.
Yeah.
And you're subtracting. Are you subtracting 65,000 times 0.025?
No, I want to figure out how many accidents it's acceptable.
Okay, let's see.
So I'm just subtracting like 65,000, and I just want to figure out how many times can I subtracting.
Okay, so 2.5 million times 65 times x equals, or is it greater than 0?
Yeah, it's just 2.5 million. Subtract 65,000 times x equals 0. So it's just like use the money you gained divided by 65,000,
Okay,
make it the number of accidents.
so it's like 38.65.
Yep.
38.
Maybe close to that number. So
it has to be less than 38 accidents.
yeah, but in this home assignment, I mean, because the z distribution is continuous, so I'm both good with like you take 38 or you take the original number. I mean, it doesn't matter too much.
Okay.
So rounding or not rounding, either is okay.
Okay.
So that means I have a binomial model. The binomial distribution mean is 25. The standard deviation is around 5. And I want to calculate what is the probability of observing a 38. And you know that probability would be very small, right?
Yeah.
Because that's like 2.6 standard deviation from the mean something. So then you need to calculate the z-score, and you use the z-score table to get the precise probability. So
Okay.
here you have 3 parameters already. So
Right.
what does that mean? It means when the company will lose money when x is greater than 38, right?
So do you just do 38 minus 25 over 4.375 or whatever the number was before?
Yeah.
38 minus 25 over 4.937. So it's like 2.73. So, okay, now I'm looking at, well, actually, I don't know if this, I'm looking in my textbook to see what the z-score is. I actually don't know if this version has it. I'm looking at the online version of the textbook, and I don't think it has the z-score tables.
Yes, it's in
Uh-huh.
the last few pages of the whole book.
Yeah, it just is showing me the index. It's not showing me the actual z tables. That's annoying. All right, I know I have them in my textbook at home. I just don't have it with me. So, all right, there's like based on the tables in the back, it will give you like it'll be able to tell which table to use or which table to use.
You have to use a z table.
Right, but aren't there a ton in the back of the book based on like?
Yeah. There's some t table. There's some
Right.
R
So
table,
definitely use
something.
Z table.
You're gonna use a z table. I can Google it right now, but you have to understand. You have to like find the probability of z greater than 2.7. What that number? They're greater
Okay.
than that number because when x is greater than 38, the company lose money, right?
Right.
So what happened when x greater than 38? You look at this formula. When x increase, z will increase as well, right?
Mm-hmm.
So the probability of losing money would be z greater than that number.
Okay.
Which means when x is greater than 38, that
Okay.
time company lose money.
Gotcha.
So I have the Z table already here.
Oh, let's see.
Just Google it. So,
Oh,
so this is the Z distribution. You can see this one.
I still see the presentation on your screen.
I'll stop recording and then record. Oh, sorry. Can you see it now?
Yeah.
Okay, sure. So this is a Z distribution. So basically, here Z equals to like 2.73 something. This is a Z, and I want to find the white area. What is beyond Z, greater than 2.73, right? So, but in the Z table, they have the shaded area, and in the table, the probability is the shaded area.
Okay.
And sometimes the shaded area is on the right, sometimes in the left. So first you need to see the distribution, what is the graph is like, and then you look at the table. The table will always give you the probability of the shaded area. So here, we can anticipate when we like look at the table, we can get a number which is pretty close to 1 because that's a shaded area.
Yeah.
We use, and that is actually the probability of winning money of that, making money of that company. And 1 minus the shaded area is the probability of Z greater than 2.73, which is the probability of losing money.
Okay.
And then we just scroll down. Here is basically what the Z table is like. It's it takes to 2 decimal places. So those are the Z number, but it's just 1 decimal place, and the second decimal place you look at this horizontal axis. For example, this 0.6, see, so this first column means Z equals 0.60, and maybe that column, this column means Z equals 0.55. Can you understand this table?
No. Wait, one more time.
In the vertical axis, it's the first decimal place.
Okay.
Of Z.
Oh.
It's 1.9, 1.8, 1.7, those things. And then what if I want to find 1.86? I need to find 2 decimal places. Then I look at the horizontal. So first, it's in this line, 1.8 this line. And then I find where is 0.06. I look at the horizontal axis here. So
but I can't see your mouse.
Cannot see my mouse. Okay.
No.
I make some not really. So so what do you think is the Z score? What is the probability of 0.12? It's just on the first few columns. 0.12. My Z score is 0.12. So first you locate
0.54776.
Yeah. That's easy to read, right?
Okay.
It's just the second decimal place is in the horizontal axis.
Gotcha. So now I'm doing 2.73. So it would be 2. So it'd be 0.98030. Wait. No, because I'm doing 2.73. Okay. So 0.99674.
That's not the case because the first one is 0. So you need to stay on the fourth column.
Okay, so 0.99683.
Yeah, that is the probability of winning money. It's pretty high. Of course, higher than the first part A.
Right, which explains point B better because the more policies you sell again, the less likely you're going to lose money.
Yeah, so in this that's true. So like in this distribution, the middle is Z equals 0, and then 2.73 was like very far in the right. So the shaded area is pretty close to 1.
So, okay, but before you said the shaded area gives us, the probability of P Z is greater than. Because aren't we looking for greater than Z? Z is greater than 2.73.
We're actually looking at the complement.
Right.
Because I
So
said
the complement would be low because we're looking for the amount of losing money. I get it.
yeah, the complement would be. I think what the question is like.
Yeah, it definitely was. Because it was what's the probability that they'll lose money.
Lose money. Okay, so we look at the white area.
And well, the chart doesn't give us that, right? Exactly. So that's why we have to do 1 minus that number.
Yeah.
So it'd be like, it's like 0.00317. So it's like 3%.
I
So
don't
it's,
think so. I think it's much lower than 3%.
did I do it wrong?
You can look at this number again.
Oh, so is this the probability? Well, wait, no, that doesn't make sense. 1 minus 0.99683, 0.00317. And isn't that 3%?
It's 0.3%.
0.3%. Duh. Okay. My brain is off today. Got it. Yes, that makes way more sense. So 0.3. So it's very low. All right, cool. I think I got that one then. Okay. All right. And can we look at the second problem? Okay, so the tire manufacturer wants its tires last at least 20,000 miles. Okay. So the probability that a tire wears out before 20,000 miles. This is what I did. I don't know if it's right, but I tried to find the Z-score again.
Yep.
So I did 20,000 minus 26,000 divided by 5,000.
Yep.
Equals, so it's negative 1.2.
Yeah.
So that's my Z-score. And then I have to find the probability based on the chart that compares to that.
Yeah, but what's the value you want to find? Greater than 1.2, less than like negative 1.2 or something? What is the range?
So I'm looking at the probability that they wear out before 20,000 miles.
Yeah.
So less than?
Yeah, definitely.
Okay.
So when you want to see what influenced the Z-score, you look at the X, because the mu and the standard deviation are settled. So you look at the X. You want to find X less than 20,000, right?
Okay.
Because as long as the tire like went out before 20,000, we get a compensation.
Okay.
So you want to find a Z which is less than negative 1.2. There's two ways to find that. If I share this one. So basically, sometimes they have two distribution. One is negative, one is positive.
Mm-hmm.
Okay, so for this negative one, you can see this is the shaded area. That is exactly what you want to find in this question, because here, like you just plug in negative 1.2, and the shaded area is just on the left of negative 1.2, something which is less than 1.2.
Okay. So less than negative 1.2 would be.
You just look at this chart again.
1.2. 0.11507.
Yeah, that is something you want to find for this question. But a lot of times in the textbook or some like in cheat sheet or something, you only have one Z distribution, which is this one. But you have to notice that the Z distribution is symmetric. So when you find the probability of Z-score less than negative 1.2, it's the same as you find the z-score greater than positive 1.2.
Okay, so less than a negative is greater than a positive because it's symmetric.
Yeah.
So if it gave me one,
actually you can use this one graph, only this table, to calculate that. So you find the 1.2 and it's like 0.88493 and
Yep.
use 1 minus that.
Gotcha. Okay.
Yeah, so you get the first part.
Okay. Okay, and then for the next one, I have to pull up the question again. Okay, what's a probability that the manufacturer turns a profit on selling a set to one customer? So I feel like this is sort of similar to what we did before now that I'm looking at it.
Yeah, definitely.
Originally, I was trying to do like the estimated value, but I wasn't sure how to actually calculate that. So it was like the probability of less than a probability of a tire falling less than 20,000 times $200. So I guess that's just the number I found before. So the probability is 0.11507 times 200.
You are doing like part C already, I think.
Oh, I
But
skipped
for part B, it's just like the it's just like the part A of the first question. It's pretty easy because
part A.
for one, we're sitting just for one person.
That's probably well.
Like these two questions has a lot in common, I think. What you have just calculated at 11.5%.
Yeah.
Is pretty similar to the 2.5% in part A.
Right. Okay. That's what I was thinking. Okay, because it's the probability from part one is the probability that a tire fails less than, or that a tire fails less than 26,000 before 26,000 miles.
It's before 20,000.
But is it still asking that? Right, like because if a tire, oh, they have to last at least 20,000 miles. I got it. Okay. A set of tires. So it's asking me that they last above 20,000 miles, which is just the answer from before.
Yeah.
Okay, cool.
But it says what is the probability of turns a profit. So it's a complement.
Oh, it's a complement. So like 89%, 88.5%.
Yeah. Like I didn't do all this problem, so you should like maybe recalculate what is the number. Yeah.
Okay. But I think that makes sense. Well, I'll double check it later.
Yeah.
Okay, so what I was doing for before, so if the manufacturer has 500 tires, what's the probability that it earns a profit after applying for your replacement? Okay, so what I started to do for this one was I did the expected value is the probability of success times $200 plus the probability of failure times $400. Which I don't know if that's right, because there's 500 tires. So you actually doing, so am I supposed to, okay, I think about it differently. So out of the 500 people, I have to calculate how many, with my probabilities from before, how many would be like successes/failures, like how many would last over 20,000 miles or not. And then I multiply those numbers by the respected dollar amounts.
Yeah, you're just doing pretty similar to the part B of the first question.
Right. Okay. So
you still have to find that three parameters in order to calculate the z-score.
So I need the mean, the standard deviation, and the x.
Yeah. Probably you'll calculate the mean and the standard deviation first because they're pretty. You can use by formula, the NP and NPQ. Remember that.
and NPQ. So N is 500.
Yeah.
The probability, I'm looking for the probability that they earn a profit. So I'm using P is 0.885 from part B.
Yeah, you could do that.
And then, well, yeah, because I guess it doesn't matter because I'm using the complements anyways.
Like you can use both actually. You can use the probability in part A or part B because they're just complements.
Right,
And
exactly.
anyhow, when you calculate the final probability, those two should add up to 1. So you choose either one.
Okay, I got 50.91. And that's the mean.
Yep.
And then the standard deviation is the square root of that? No.
No, you use NPQ.
Wait, that was NPQ. Sorry, hold on. I just calculated NPQ, I thought.
Okay.
Right, so that was the
So
50.
the standard deviation is the square root of that.
Okay, so then how do I find the mean?
You use NP to find the mean, right?
Okay. But then am I using, sorry, I guess I'm using the mean that they do earn a profit. The probability that they do earn a profit.
Yeah, you can do that.
Okay, 442.465. So then I do, for the z-score, I'm doing 500 minus 442.465 over the square root of 50.91.
What is your x in this question? You have to worry about what is the break even situation.
Oh, I'm doing the break even. I'm not just doing 500 tires.
Yeah, because you want to find like
So am I doing, okay, so they sell 500 tires. So 500 tires times $200 minus, they replace, so 400 times X equals 0.
yeah, I think that is. Yeah, I think that's right.
Right, because they sell 500 tires, they make 200 on each, and I'm subtracting the loss, which is 400 times how many would fail. So that's my break-even point.
Yeah.
Okay, so I'm getting 99,600 equals X. That doesn't seem right. Does it? That's too high. Because they're talking about 500 tires. Okay. Oh, okay, 250. So it's half. Oh, that makes sense because they lose half if they fail, or they lose double if they fail. So 250 equals X here. So now for my z-score, I use 250. that makes
Yep.
sense.
Yep. So you want to find like more than 250 success, right? You want to
Yeah.
find more than 250 tires, which can last more than 28,000 miles.
Last more than 200. Yeah. Okay. So let's see, square root of 50.7.13. All right, well, this is really high. So does this make sense? Z-score is 26.7 or 26.9. Let me double check that. That's why I don't use my phone as a calculator. Yeah, is that too high? If Z-score I got to be 26?
Yeah, it's very high, and
Yeah.
like what like what Z do you like greater than that or less than that or something? Because what you calculate is like negative 26 something, right?
Yeah, negative 26.
Okay,
But it would
so
be greater, Z is greater than negative 26.97.
yeah, because you want X greater than 250, right? So every time you're not sure about what is the range, you go back to say what is the X. A break even is 250.
Oh,
So I want to find more than 250 tires that
right.
can last 26,000 miles. So you want to find a z-score which is greater than negative 26 something. That is essentially 1, because if you look at this table,
Right, because the odds of it, I mean, Z-score being so high means the percentage is incredibly, well, low in this case. I mean, high, that it won't
yeah.
fail.
So basically, you want to find the white area here.
Right.
By the way, it's the same as the probability of z less than positive 26, right?
Yep.
So here you can the shaded area, it goes up to like z goes up to -4, and
Exactly.
the shaded area is already very, very close to 0. So when z goes to 26, the shaded area is essentially 0, and the white area is 1. So in that time, the probability of making a profit is 1. Losing money is 0. I'm always making money.
Yeah, I guess that makes sense. Right, because
I guess it's like,
that seems a little too high, but I guess it is fine.
yeah, because I'm selling to 500 people. The compensation is too
Oh,
low. The compensation, like I gain $200 for each sale, and then if that tire fails, I
yeah.
only need to pay $400 back. It's like the compensation is too low, and given the high probability of not failing, and given that I'm selling to 500 people, that the basement was so high, and so I have a very high probability of gaining money.
Gotcha. Okay.
So I guess like there's two problems are all about central limit theorem, and you should like get familiar with how to find that x, because mu and phi and lambda, I don't know how to
Yeah.
sigma something, not the sigma. I don't know how to pronounce that. It's just I just call that standard deviation.
I don't know
Like
what
the
it's called either.
expected value,
So
the standard
sigma
deviation is pretty.
squared.
Yeah, sigma. Okay, so they are very convenient to calculate. You can just use the formula.
Okay.
For the
Yeah, I
x.
didn't read. He told us to read chapter 8 first. So I read chapter 8 in the textbook, but didn't read the chapter 12, which I think talks more about the normal distribution and the central limit theorem. So I have to read that because I'm still not sure about it or not confident in it, I guess.
The x is different. X varies in different situations.
Right,
So you have to
because
find
x is the
range.
variable based on units or whatever it is.
Yeah.
Okay. All right, cool. I think that's all my questions for now. I think I might review it and then come back maybe tomorrow night with some more answers, but depends on how much work I can do today. Which is probably not a lot.
Sure.
Thank you so much. I appreciate your help.
Sure, no problem. Have a good Sunday.
Thank you. You too. Don't do too much homework.
Sure.
Get some sunshine. It's beautiful out.
Yeah, definitely.
All right. Well, thank you again. I'll talk to you soon.
Sure. Bye.
Bye.